In the previous calculus 1, you learned the derivative of trigonometric function. Your understanding of the derivative of trig function is very helpful to perform the derivative of hyperbolic function. Let's look back at the formula derivative of trigonometric function. We have 6 formulas under derivative of trigonometric function. The first one is derivative of sin x. The answer is cos x. The second one is derivative of cos x and the answer is negative sin x. The third one is derivative of tangent x and the answer is sec squared x. The fourth one is derivative of sec x and the answer is sec x tangent x. The fifth one is derivative of cosec x and the answer is negative cosec x cot x. And the last one is derivative of cot x and the answer is negative cosec squared x. Now, what about the formula for derivative of hyperbolic functions? If you look at the left and right columns, both are very similar. Their difference is, in hyperbolic function, all of which need to be placed h behind it. And the first three functions are positive when differentiated, while the last three functions are negative when differentiated. Okay, now we look at the first example. The first example is quite simple example. Let's say we want to differentiate y equals to sin 2x. Okay, here are the solutions. We are given y equals to sin 2x. Then we differentiate with respect to x. Okay, when we differentiate y, the answer should be dy over dx. And then when we differentiate sin 2x, we can prepare the space for differentiate sin 2x. And we can refer from formula derivative of sin x. Derivative of sin x equals to cos x. Okay, and then inside sin x, we also need to differentiate. And we can refer formula derivative of 2x. And in between, mass multiplication. And then we can put what the correct function inside this circle. Okay, when we differentiate sin x, the answer is cos x. So when we differentiate sin 2x, the answer should be cos 2x. And then when we differentiate 2x, the answer is 2. Okay, after we differentiate, we need to simplify. What need we do is we just bring 2 to the front. Okay, got it? Okay, now we continue with example 2. Still simple example. Differentiate y equals to sec x cubed. Here are the complete solution. Okay, we are given y equals to sec x cubed. Then we differentiate with respect to x. We differentiate y. The symbol is dy over dx equals to, and then to differentiate a sec x cubed, we prepare the space for answer when we differentiate sec x cubed. We just prepare the space first so that we can compare with formula derivative of sec single x. Okay, and then we prepare the space when we differentiate x cubed. Okay, and we can refer this formula, which is power rule. Okay, and then in between of the circle should be multiplication function. Okay, when we differentiate sec x cubed, we can refer derivative of sec single x, which is equals to negative sec x times x. So when we differentiate sec x cubed, the answer should be negative sec x cubed times x cubed. And after that, we differentiate x cubed using power rule. And the answer is 3x squared. Okay. And then we need to simplify the answer. We just bring 3x squared to the front. Then the final answer is negative 3x squared sec x cubed times x cubed. Okay. Okay, now we continue with example 3. Differentiate y equals to cos e the power of z x. Okay, here are the complete solution. We are given y equals to cos e the power of zx. Then we differentiate with respect to x. When we differentiate y, the symbol is dy over dx equals to, okay, from cos e the power of x, we can write the circle for cos e the power of zx, and then we prepare the space or the circle to differentiate cos using this formula. Okay, using a hyperbolic formula. Okay, and then we prepare formula when we differentiate e zx. Yeah, we prepare the space. Okay, this is the formula when we differentiate exponential function. And then we prepare the space when we differentiate zx. Okay, and in between must multiplication function. Okay, then when we differentiate cos e zx, we can refer formula derivative of cos single x. Okay, derivative of cos single x is a basic formula for hyperbolic function. Okay, that when we differentiate cos single x, the answer is negative cosec squared x. So when we differentiate cos e the power of zx, the answer should be negative cosec squared e zx. Then we differentiate e zx, we can refer formula derivative of ex. When we differentiate ex, the answer also ex. So when we differentiate e zx, so the answer also e zx. And then when we differentiate zx, okay, firstly we need to change zx to exponential to x the power of half. Then we can differentiate using power rule. We move half to the front, x, and then negative half. Why negative half? Because we minus 1 from the original power. Okay, and then we can move down the power of negative half. When we move down, it can be x the power of positive half, and x the power of positive half is zx. So the answer when we differentiate zx is 1 over 2 zx. Okay, so differentiate zx equals to 1 over 2 zx. Okay, from here. Okay, and then we can touch up or simplify the answer. So our dy over dx is, okay, we can we just rearrange. We put e set x to the front, and then the symbol is negative from here, and then 2 set x is denominator. Okay, so the final answer is dy over dx equals to negative e set x cosec squared e set x over 2 set x. Okay. Coming up next, example 4 is about implicit differentiation. So, stay tuned. Bye. Assalamualaikum.